Wish YouTube didn't ban content for music, because I could really use some drum and bass right now. Alright, where I left off yesterday, I was trying to basically do this little table creator where I can insert a specific subject, not my relationships, not my domains, not my attributes yet, to create it. Swedish MOFS suggested that, and I ran into an issue. It didn't actually work. It was adding all of the primary keys for the realm, class, family type, and base table inside of a realm table, and I was trying to figure out why. So I left the stream about 2 hours and was like, I need some food, and slept on it. So this morning I came back to figure that out, to figure out why, and it's so simple that it's ridiculous, where it was the data set ID. This is how my code looked like before the modification. And what would happen, to get the full picture, is that during the cursor, these items, when you're setting variables inside of a cursor, they will keep the value that they had in the last iteration if no data is returned. So when we got down to here, realm being first, it did not release that data set ID. Therefore, this always failed. It never created a new data set ID for the class, family type, etc. Thus, my table creator did not work. So it was something as simple as nulling out a variable that actually fixed this issue. So that's something that I have to actually keep in mind, and going to do really quickly is that every single variable that we set in a cursor needs to be cleared out. So this will help us make sure that we're not running into this type of issue again. And some of them don't matter. For instance, this is being set by something that we're getting past. And nope. That matters too. But that was the issue. So now, once I save this, I should be able to run a procedure that will automatically start building my objects. So that's what I'm trying to do anyways. So that was it. That was crazy. Thanks, Swedish MOFS, for the direction, because now I have a lot of stuff I can do. All right, so back to what I was doing yesterday. I created a new subject that I'm going to be modeling messages. So we start entering message information, or at least getting feedback from things that are running. So I created this new subject to model, and then I'm supposed to be able just to run this and actually get it created, but I have the execute code commented out. So I want to, what, kitty? So I want to get this code uncommented so it actually build the objects. And that is in my SQL table creator. So today is also Saturday. I'll be updating all my databases and this code on Coffee. So in case you've bought and downloaded, you can just go re-download. You don't have to repurchase this system. So where is it? There it is. So now, what should happen is I do not have messages. Do not have any errors. Completed successfully. But I have my message. Table's built now. So at least in the system, few live streams, probably about 6 hours. I'm at the point where I can build my database units, the MASH, main archive, snapshot, and history, and I can build my tables for at least the basic RCFT variety. Now, to make these usable because of the nullable, not nullable definitions, no, I don't print it out anymore. So I go down to my messages. If something's not null, we want to actually add defaults to it. So we don't have any defaults here, but the tables that we start with, because I don't want to build everything from scratch, we have all these defaults. So I'm going to create a default enforcer, and then we'll go into creating more than just the non-clustered primary key. We will need more things, definitions on how we access this. So all this will be data driven. All of this will be created by the system itself, so we don't have to worry about that. So we can get rid of that. Alrighty. So actually, I want to save this as oh yeah, that's my app. I want to save this as what? Creating new subjects, because this is what I'll have to do. Just make sure the file groups and files are there, and then create the subject. So I'll be good on that. Alrighty. So for defaults, pretty simple. I go back to my favorite tool ever, and I'll essentially just have to create another relationship between a definition and a data point type, because data point types are columns, data points in a data set. So let's create some definitions. What do we have? System definitions for object construction. These are constraints. And so this controls the data point being null. This would be a good spot to say these are for defaults. So data point defaults. This definition controls the default values for our data points. I'll just say default. So now I can create the different types of defaults. It gets pretty interesting. What number was that? 20. So I have something that is not null. We want it to actually be null, but we can't use uppercase because in here it will mark it as a null. So I'm going to say this is a null. This definition is for a null default. And again, small exception to the rule, null. So I will have default values that are null. I will have default values that are true. This definition is for just copy this, paste it down for a true default. I go back to my cap case, true. If I have true, I will need false. And I will need one more for a very specific default that happens in our structure. So this number will always remain the same in every column or in every row in a specific table, but every table has a different value. So those will never repeat. So I have this custom default definition. I'm going to say that the default is from my function. All right, so given what we do in the system where we're only passing payloads, we're only worrying about this context object. We don't have to worry about what the name is. We're going to treat our functions like that. We're going to send it a JSON object, and based on that object, it's going to know what it needs to do. So when I'm creating these defaults for these data point types, it will run into a function, look up a relationship between the definition and the data point type that will describe what function it belongs to. So it'll be able to grab the ID I need, or the value. It's not an ID, it's just value. So for a function default. So that's going to be this weird relationship. Actually, I should say for a default originating from a function. And the reason why I do function instead of process is because calling a function and calling a procedure are completely different. But yeah, so we have our defaults, and I'm going to copy this information to my favorite tool, just so I know what I'm assigning it to, and then I will have to get a list of data point types. So I can assign defaults to them. And I need this specific data set number and the ID. I don't need most of these. So I will go back and basically create a relationship between these definitions and these data point types, but I need that function for the specific data set number. So I'm going to create that function real quick. It should be pretty simple. New scalar function, FNC get specific data set number. Actually, all I have to do. So I will give it my, come on now. Is this off? No. It just doesn't want to work in there. So this is the only things that I'm using, but it won't be an output, and technically we won't need a response because we don't have this output in a function other than what is being returned. So in fact, what if I took this approach? What if I say my response and my functions are what's being returned? So I can keep the same pattern that we've been using. So I will say set the JSON response is empty. Set the JSON response is JSON modify the response root. I will say specific data set number is what I'll be looking for. And it would be the specific data set number value. In order to get that, I will need to know what data set I'm looking at. So I will need a data set name. Or an ID. So this will help me make this a little flexible, so I'm not always looking for a name. I can just say, hey, here's what I have. I have a name or a data set ID. So I can say name ID. Oh, I totally messed that up right there. That's fair. Thank you, SQL, for yelling at me. That's where I want to add it. Oh yeah, and this guy. This is the actual value that I'm looking for my default specific data set number. So I could say the data set name is the data set name from the JSON that will be coming in. And we want to look at the root. We'll say we'll get two pieces of information from this. We'll either get the dataset name or the dataset ID. Oh, that's where they should be. Next up is the value. So this will be at the dataset ID location, this will be at the dataset name location, and that's it. And that's something simple. Is if I have a dataset name, set the specific dataset number, actually select the specific dataset number is the dataset specific dataset number source from the dataset select view, where the dataset name is our incoming variable. But if I don't have that, say else, the dataset ID is not null, then get it where the dataset ID is equal to it. So I have this simple overloaded function. But to associate a function to a definition, I actually have to have it in my system, and I do not have anything in processes right now. I believe I don't. So that's just another thing that we define. What kind of processes will we have? We will have functions. This process realm is a function. We will have procedures. We will have jobs. And just to get two other things that I know are coming, we will have web services, or let's just call it external processes, so we can define them as C# API, whatever we need. We have this external type process because it's technically f of x, right? In and out. So this process represents external items. And finally, an abstract process. And quick note on abstract processes, no, getting a little off topic, but it's kind of important. Is we look at a process as f of x, where something goes in, procedure, function, job, whatever. Something goes in and something comes out. So sometimes nothing comes out, but still nothing is something, right? Yes. The answer is yes. So a user input, where a user messes with a website. they mess with it, the website does something, it responds. So that's kind of like an abstract container, is a user using something that, that thing is a process, it's a function. I'm clicking a button, click, what comes out? I'm scrolling, what comes out? So that is what this abstract container will hold, which is going to help us in the long run building this import anything type database. So I'm going to focus on functions right now. What class of functions? Let's say I'll just have two. This function is a scalar function. Table valued. What family? We're going to keep this unassigned right now. This family is unassigned. And essentially, we're going to repeat the same thing. So we don't have a classification for it, but we want one. So this allows us to come back and reclassify the data that we have. So my first process that I will have is an unassigned function, and the name is get specific data set number. This function gets a specific data set number for a dataset ID or dataset name. Say get specific data set number. In the column header, I'm going to use this for something else, because the column header, not something else, but usually represents the value it is in like a pivot or in a JSON object. So if I say the column header is specific data set number, I should be able to get value from JSON, JSON value my payload, and where is it at? Is at the root column header. So some simple dynamic code to allow us to send a payload and then pull a value and make it dynamic enough that yeah, it's going to work. So process type ID 1, I will need the specific data set number. So I'll just copy this code and put it in here. So these are basically my relationships where I'm going to relate defaults to data point types. When I get to data set specific or specific data set number, I'm going to say that's a function definition. I'm going to relate this function definition to this function in one relationship and this data point type to this function in another relationship. So when they combine, I get like a triangle relationship. So because this exists, this relationship is true, and this relationship is true, it gives me one point of fact. That's kind of like Boyce Codd normal form, where we have these three different objects that create one truth. So more definitions in here. So I do have definition of data point type. So if I look at my Excel document, I can relate these two, no problems. But now I need a definition to process and a data point type to process. So definition to process. And data point type to process. Meow meow. 1008, 1009. These are functional. These are just for my two new ones since I already had one. Oh, what numbers were those? 7 and 8. These are 4 objects. And definition data point type was 107, 106, 108. So 8, 9, 10 are the ones I have to look at. So 108 nullable fields, but in this case we are looking at a different type of relationship. Instead of nullable fields, we're looking at defaults for columns or for data points. So we'll say default. So we have two different types of relationships under definition of the data point type. And for the other ones, we essentially can keep the same default. So we have, actually, it's going to be easier to look at in the tree view after I finish this. System relationship. So we have two definitions for data point types now. One of them for is this data point type nullable when it's in our table or not, and the other one is for our default values. Now we have a definition to process for default and a data point type to process for default. So those three things should allow me to relate everything together. So I will say, give me the type ID also. Give me these three objects. And create my relationships. Alrighty, so this is my relationship ID 1, 2, 3. And these are my parent and children, which goes primary key, table number, primary key, table number. And sequences won't matter here. So we don't need to care about these sequences, but these are the two pairs of columns that are going to matter. Alrighty, so definition to data point type for a default. And let's do that. So definition to data point type. Data point type is the child. Definition is the parent. I'm going to bring these down so I can read them. Actually, I'll take these two so it's easier on the eyes. There we go. Alrighty. So the sequence can be nullable. And we want it to be a null. The foreign key cannot be nullable, but we want the default as a null. Actually, let's work in reverse. Let's make all these defaults null. So even on the not nullable fields like cluster ID or sequence, it's going to default to null, raise an error, and boom, you can't do it. So we're creating a form of control. So what do we want as true? This is where, you talk with your team or whatever. When we get a new record into our system that doesn't have an active flag, do we want to consider that active? It's like, well, I do. So I'm going to make this the true default. Archived? Well, no. When we get a new thing into our system, it can't already be deleted. When we get a brand new thing into our system, it can't be cleaned. It doesn't have any display information or other information. It's not on a schedule yet, because in order to create a schedule or in order to do something for this, it has to already exist. So it won't have security. But I want to say by default, I will not trust the data. I have to specifically say I trust the data in this. Additional columns is an abstract data type, so it doesn't have a default. Primary key implied is a nullable item, so we're going to give it a null. Let's see what else. Okay. Specific data set number is going to be the function that we just created, and the rest of these will also be nulls. We don't want anything like this to, this is our relationship table. If we don't have a parent or a child, we want to raise an error. So these can't be nullable, and we're going to have a default value of a null. So for the rest of this, it's the same all the way down. Who owns it? I own it. And what's the specific data set number for the system relationship table? So now looking at that triangle relationship, since we've related defaults to our data points, we now have to look at this function relationship, which is third from the bottom, 1, 2, 3, 1, 2, 3, right here, 28. I'm going to mark that so I can just refer back to it. So we have this default that comes from a function, so we have to actually relate the data point type to a function, data point type to process. So this is now the parent, and the process will be the child, and we only have one, and it's 1 and 6. So now this relationship is different, but going in the same table. So data point type to process. Now we have this chain. This is a function. This is the data point type of the function. And one more to create the circle is definition to process type. So we have our process type ID, and we have our definition. And it's because we do want to make that triangle join. If we just say, hey, what definition is our functions, we're going to have a ton of them. So we need to say, oh, and it intersects with the data point type. So that's where we get our triangle relationship. And the rest of this is the same. So I should be able to copy all this data and fill my relationship table with more relationships. Boom. All right. Now, I'm just going to close everything so I get a fresh start. Okay. So for my procedure to actually set the defaults, we want to figure out what are we looking at. And we want to do it one at a time. So I will have a chain of procedures. I will have something that generates the default for one data point, something that will take in a data set and iterate through all the data points and move forward. So this will be my create statement, and this will be the data set. So I can have something else that says, oh, for a subject, get all the data sets, create all the, go all the way down. And what this is going to allow me to do is choose where I want to start in the future. So I don't always have to supply a subject. I don't always have to supply a data set. I have the choice. Do I want to do the whole thing, a partial, or just one item? So we're going to create 3 stored procedures to take care of each of these, isolate what we are doing. So we'll work at the very bottom. So at the very bottom, we are going to be expecting a data point ID. So from that data point ID, in order to create a default, this is what we will need. We will need the data set name, the data set ID, because to get a data point ID, it has a data set ID attached to it, and then data set ID to data set name. And that means we will need the column name, because that's how we get this. So that's the data point name. And we'll need some definition information. So this will also be our data point name, and this will be our actual value. So we will need a few things. Let's see, a definition. Three of them. Let's just do them in groups. And the process name, because we will be dynamically getting data back from that function. We will need our dynamic SQL. Do we need anything? We need the process ID. Right, is that how I gotta draw this out? Sometimes, it's the whiteboard, right? So focusing on the definition, the data point. we have those 3 relationships where it's definition to process, definition to data point or type to process. So we need IDs for each of these. Data point ID, definition ID, process ID, and then we'll need the definitions for each of these. Data point type. So many relationships. Oh wait, they're in front of me. What am I doing? Data point type to process. Definition to data point type, and definition to process. So that will get me my triangle relationship. So now I can basically construct this. So I will set my, get my comments in for the procedure. This would be under initialization, and these will be my declared variables. But since it's a procedure, this will be the inputs. So I want my SQL base script to be this statement. But there are pieces in here that I need to remove. So I will need that dataset name. Here's the dataset name also. I will need the data point name. And it's here also. And I will need the default value. So let's format this a little better. So that's it. So now we go for the code. How do we get all this information and replace it? To keep that isolation in mind so we can start at the subject, at the dataset, or the data point itself, we're not going to expect a dataset ID to come in. The only thing that we're going to expect in the payload is a data point. So we want a data point ID, actually, because our system, I hope that's the data point ID. I just mashed my keyboard. Our system, I mean, everything in our tables are named the same. str name exists in every table. So giving it a data point name, it's just not going to know. So we want the data point ID. So from that data point ID, we need to get the JSON value from our payload at the data point ID location. From there, we need the dataset ID and the data point name. From our data point, where the data point ID is the incoming JSON. We need the name. From our dataset table, or the dataset ID, the dataset ID. Oh. Some initializations for our relationship. Let's just do this shorthand. Do I still have that up? Awesome. So let's do this. We need these three relationships. So let's use that. Replace tabs with quote, comma, quote. Replace the beginning with the operating tenant and a comma and a quote. And replace the end with a quote. Doesn't give me this one, but that's okay. Awesome. Oh, that should be an initialize. Okay. So function for system relationship. 3 times. These are our 3 relationships. And I don't have them. Awesome. So let's do this. That's the name. Oh, I'm going to separate these out. Strip me out. I like working with this column select because it really does show you what the patterns are. Definition to data point, definition to process, data point to process. Data point to process is last. Definition to data point is first. And that should be good. And for readability in code, we're just going to make a new line so we don't have to scroll to figure out what's going on. There we go. Get my different relationships. All right, so I have the data point ID, the dataset name. Now I have to get the definition for the default value. That should be easy. I need the definition name. Definition to data point type. Definition to data point type from our definition to select view, where the definition ID is in our relationship table. Because it's definition to data point type, it's going to be our parent. Relationship primary key parent applied from our relationship, where the system relationship type ID is our definition to data point type. And I didn't get it, did I? Yep. The thing that I needed the most, I didn't even define. The data point type ID. That's funny. All right. Data point and the child, based on our relationship, is the data point type ID. So that will tell me what it is. It will be one of these: null, true, false, or function. So that would actually be good enough. Is that good enough for everything except for function? If the definition is a function, we need more information, which is all going to be from here. So if the definition for the definition to data point type, and we want the key name, if that's a function, well, get that function. Get the value from that function. So in order to get that function, we need the relationship. If we look at our system relationship definition, it would be definition of process, where the child is the process and the parent is the definition. So the child is the process and the parent is the definition. Oh. And like I said, I'll repeat it again. The parent, or the child, is the process. I think we want, since this is a function, I think we're going to want the column header for this one. Because that's, right? I think that's where I defined it. Yep, so that'll be easy to get. So we don't need a key name, we just need the header. So we can dynamically pull the JSON from the response, because the response of the function is going to be a JSON object, and that header is going to be just like this, the location that we need. So, like, honestly, get the value from the function, get the value from the data returned. So it'll be like our default value is from this function's response. It will be the root plus the column header. So I have this really dynamic piece of code. We don't have to say, oh, is specific data set number null? Is this null? No, we just go in, edit data, and boom, we have another thing to do without coming back and messing with this code. So that works, or that should work. Process, we didn't want the name. Oh, we do want the name, duh. Because we need to execute it. All right, so I have the process ID related to this definition. But do I? Because the more I relate for this simple data point type to process, did that backwards, no problems. Definition the process, or the parent. The more I relate for this definition of a function, and this is a process, I have to make that intersection. So it's not just this data point type, or it's not just this definition ID, is that the process needs to intersect. So I don't just need to send the process forward, I need to send the, the child down. So I need the same thing, because we said our relationship is data point type to process. So the child of this relationship is process, and the parent is that data point type. So this is what creates the triangle where we have this definition to process, process to data point type, and definition to data point type. This is the triangle that always get us one function to execute. And that should be it. Now it's just executing that function. So I'm going to create a special one-off dynamic SQL to handle the function only. Because I don't want to interfere with the other things. Not just, I do have my parameters. Excellent. So because we're keeping the same kind of pattern, let's see. I'm just going to get the response. So select at JSON response is equal to dbo dot the process name with the operating tenant, the payload, and oh no, that's it, it's a function. Response is out. So just the operating tenant and the payload, because all of our functions are going to start to look the same. If I go down here, get specific dataset number, just these two, and the output will be a JSON object. So that should be it. And I can say, since we're not going to use exec, we're always going to use sp execute SQL. I can say that I will have essentially this. Parameters, parameter defaults, and this is formatted, almost, all these unnecessary characters. This is formatted exactly how I want it to be. This is my operating tenant, it's an integer, my JSON, and my output, response JSON. So that should be what I need. So if this is a function, get that value from a function. So I'm going to set this execute is what my base is. My function. I'm going to basically make immutable objects. So I'm going to put this into this procedure and then modify it in case, it won't be in this case, but just in case I get multiple data points themselves. So I will set my execute, and I just need to replace that execute. I just need to replace my process name token with the process name from the relationship. Then I need to execute the SQL. I want to execute my function, give it the parameters and the parameters. Because I know that's what I need to do. I'll just do that. And then the column header will do all the good stuff. So let's just make sure what I need in here, dataset name or dataset ID. So I want to go ahead and modify that payload before I send it. So I just want to set the JSON payload, JSON modify the payload dataset ID with the dataset ID that I have. So that will inject, I will have a data point ID and a dataset ID that will just inject that into the payload. It will run this and it will give me back my default value for function. Since we're just doing text replacement, it really doesn't matter what the data point is until the default is ran. So I will say if it's not a function, then set the default value to the definition key name. All right. Let's test it, because essentially this should be it. Dataset ID of 1. Let's get a true, a null, true, false. Just to test it, and the specific dataset number. Let's get 2 of them actually to make sure that it changes. Because that would be horrible. All right, and I'll select the default value. Awesome. So the data point ID for str abbreviation is null. That is correct. We want the default to be null for an abbreviation because they're not really important. So say active should be true. Everything that's inserted, my definition is it should be true. Awesome. Archived, well, when you insert data, it can't be deleted. You just inserted it. False. In the moment of truth, did we write dynamic SQL correctly? 39, and does it change? 26. Awesome. So this, kind of confusing, not much code. Most of it is just, select. That's pretty nested. Dynamic SQL, and boom. So the last piece is to create this. So what I'm going to do is I'm going to just copy everything I need. Oh man, I forgot one thing, one very important piece. No problems. I got to figure out what database I need to execute this in. But we have that. So use database name. But we have all that information. I could just take it from here. So when I have, and just copy my tokens so I can bring them down and work on them at the bottom instead of scrolling back and forth. There we go. This means I don't need this, but I need my database name. So essentially it's going to be this. But from here, my database ID is the dataset's database ID. So that should give me my name, dataset name, default value, and that's everything. So I want to set my SQL function, or no, SQL execute is my base SQL. So now all of my token data is in execute. And I have my replaces up here, right here. I'll just use this as a template to speed things up. Where we're gonna get rid of that right now and get rid of this and do this 4 1 2 3 4, and we'll do this and that and this and that and this. Dataset name, data point name, default value, database name, print the SQL we want to execute. Use system name, alter subject class, add the constraint, default 26. So what if the constraint exists? Oh, I did that on the function. Yeah. Drop it. So can you do, I wonder if you can do a die on constraints. Is it this way? Nope, it's yelling at me. So is it this way? Drop constraint on this if exists. Nope. Unfortunately. So we are going to not care. Say begin try and try. Begin catch and catch. Die functions make things so much easier, and trying to, what am I trying to say? Trying to go into an information schema and all this stuff, it just wastes all this time. We don't need this time. We know exactly what we want to do. We want to drop it if it doesn't exist and then create it. So if it doesn't exist and we get a fail from our drop, does it really matter? No, and it does. I don't think it matters. So we're just going to catch the error so the thing, the outermost thing doesn't fail, and essentially ignore it because we want to actually create that default. So that should be the whole thing. Use system main, try to drop it. I wish constraint did have a drop if exists. If you're watching and you know that they do, let me know. I will change this, but I'm not gonna look it up and waste time. I'll come back to it and make a note on Trello. So boom. Now I can just execute sp execute SQL, and this bottommost procedure is done, and this is where all of our code is. The other two procedures are going to be way quicker because they don't really require much. So let's do a new procedure. These are my headers. This one requires a data point ID at minimum. So to keep the naming in line, this is a procedure. It's for the system, messes with objects, the creation of objects, and this actually executes SQL for defaults. it needs my standard parameters and then the rest of the code. So we will take out this data because we don't need it anymore. So because all of this stuff is on Coffee, in case you really like this and don't want to build it yourself, I'm just going to go one last kind of overview of what we're doing and format this up so I'm not just, I don't want to say selling, but you're just paying me to do the work for you. That's all you're doing. I'm going to comment this code. Get system relationship for the definition. I'm going to comment this loosely. Type. Just to make sure that we're not doing anything else. Sweet. Begin code. 1, 2, 3, 4. Get data point. ID from payload. Get data set. ID. Data point. Name. Data point. Type ID from data point. ID. H. Data set. Data base. Data point. Data set. Data set, database. See, everything's in a pattern. Everything. If you can use find and replace, it's a pattern. Using get definition for the default value using this relationship type. Nope, system relationship type, and we're on 4. If definition is function, we'll move to 6. Get process ID 4. Where definition of process and process exists in data point typed process. Dynamically execute the function. Get the value from JSON response using the process column header value. oh no, set get set dataset ID in the payload. Execute. Get the value from the response. This is an else. And what I like to do with these is say else definition key name is not function. Oh. Just so we don't have to scroll up to see what the if statement was. Set value, default value is the definition key name. Oh, I can't do that in MS SQL. I totally forgot. I thought I could. Actually, at bit equals true. Can we do this? No. Oh, what? What? That's messed up. They need to bring that back or put it in Microsoft SQL. That's unfortunate. I don't want a 1 or a 0 as a key name for this, but I need to convert it to a bit because true and false don't work like they do in other places where I actually have to convert. If the default value is true, then convert it to 1, else 0. If it's false, 0. I mean, else leave it the same. So I can replace that before I execute. Execute. It's 4. Replace tokens. Execute. Okay. Alrighty. So now we can basically say create SQL defaults, and we say from dataset. So this will take in a dataset ID. And then all we need to do is essentially call this procedure. So we can get rid of basically everything. Initialize comments. Say we want to declare the dataset ID. Generic integer, and we want to declare the data point ID, which is what we need for the procedure we just created. And to keep things in kind of like React, the immutable state, we want to create a local JSON payload, so we're not modifying what's coming in. That will just keep things separate. It's an additional step that we probably don't need to take. We could just say, hey, JSON modify data point a lot, but you know, I think it's good to keep things separate so we're not overwriting. So from the incoming payload under dataset ID, we'll get the dataset ID, begin code, iterate through data points from dataset ID, get dataset ID from payload. Cursor, we're not modifying the data set table at all, so I can use local fast forward. This is a data point cursor. We want the data point ID from data point select view, where the data point's data set ID is the data set ID we pulled. If no data set ID is given, this will never run, so that's cool. I'm going to refresh my cache so I can say execute the defaults and send almost everything forward. But in this case, 1, 2, 3, 4, 5, 6, set local payload. Oops. Is incoming payload. And then modify local payload, add data point ID. And execute. And send the local payload. So now this will have the data point ID and other information. If we get a data point ID in here, it will overwrite it. This statement will overwrite whatever it was when we received it, but just keeping it separate really does help. So that's it for the dataset version, and essentially the subject version is very similar. So I could say save this dataset ID. From subject, wherein we'll need all this stuff, but I will actually need a subject ID because that is what we are getting from our incoming payload. And instead of data point, it'll be data set. And this will remain the same, but where the data set ID is in a relationship. Again, select system relationship. I don't know if it's parent or child. Let me figure that one out real quick. System relationship. I think it's child, but I'll get all my data here. Anyways, subject to data set for integrity. System relationship. Primary key of child applied from the system relationship table, where the system relationship type ID is the type ID. I own it. Replace tabs with quote, comma, quote. So that will give me all data sets, including files, database files, and we don't want that. And dataset type ID is in, we'll just get it from our tree, our dataset tree, where it's a table. Standard table. So that will give us our realm class family types, everything that's necessary. So we just need standard table, and these are irrelevant. Dataset type ID, where the dataset realm is a table, and the dataset class is standard. So that's it for, oh no, almost, yep. Add the dataset ID to the local payload, which will be sent down to from dataset which will then pull the dataset ID, add a data point ID into what we need it to, into the payload, and run it. So I created a new subject at the very beginning of the stream. It was messages. It had realm class family type. It has no constraints on the realm or the base, so no constraints anywhere. But all the data should exist, so technically I should be able to run this to really test, see if it works. So I'm the operating tenant, and my payload will be my subject ID of, I don't know, I don't remember. I never remember. Obviously no output, but select star from subject. What is message 15? So this should work. Boom. Data type. Oh, yes. Yes. I forgot. What is the format? It's a different format. I think it's like double parentheses versus single parentheses, because SQL can't be consistent. If SQL was consistent, then we wouldn't have these problems, right? What's null? Sequence is null. Single parentheses. Oh. No, see, it shouldn't care. Double parentheses for numerics. So what am I getting the error on? Is it the key name? Did I define the key name incorrectly? Key name's text. Type ID is text, text. That's my error. Conversion failed while converting the varchar value. So it's a comparison error. Oh, yes. I bet. I bet. Not a lot of money, but just enough. Ha! No. Oh, okay. That's fair. I appreciate that. Let's... I hate errors in general, so I will say... this. Database name, where's data point type? Okay. We're just going to skip primary key. It's not hurting anything, but that is fine. And just so I'm not all over the place, because I am all over the place, I did get all of them created, so this does work. But I don't like those errors, and the only thing I really need to do is, instead of wrapping this entire thing in an if statement, we'll do it right after data point. We'll say get data point type key name for data point type ID. And say if the data point type key name is not equal to primary key. And I always like wrapping with actual begin and ends, so I don't have to worry about it if I ever have to come back. So that should at least get rid of those. Oh, all right. I hear you. Wait, no. Oh, yes. Damn it. Wait, no. Could not complete cursor schema changed after the cursor was declared. So what would have changed? None of these relationships. Oh, I'm changing. I got it. I'm altering the table itself. So there's the two types of cursors. Fast forward. And another one that takes a snapshot of what you're looking at in case your object is modified, which it shouldn't actually be modified, but we're going to see if that's the case, because I'm not modifying anything in here. That was the case. So now we have this awesome little thing that we can run that will iterate through, well, our entire subjects for right now and create defaults. So every time we create new history tables, archives tables, whatever, because they'll be related to the subject, we can just clean house through the entire subject, no matter where its location is, or a single data set a single data point. So kind of the same thing here where, yeah, I'm going to create a file in the file group, but normally I do them both at the same time, so I might as well just do them both at the same time. So we have a table creator that, well, we tested and finished this morning, and we actually did our default enforcer and creator. What's next? Indexes. Foreign keys. Did I create the foreign keys? On messages. That'll usually tell me. Nope. So foreign keys are going to be next. Which should be super simple. This is just because I don't even need to do this, but I will do it. I have a table. It has a foreign key. If I exist in the same database, I will want to create it or else I will skip it, and that is mainly because every single table has a tenant, which does exist elsewhere. So I will be looking at foreign keys and foreign key parents. Is that correct? Select the tree for data point type. Got it. Select the tree for data point. So foreign key and foreign key parent taxonomy ID. And that is it for keys elsewhere. So this will be if in foreign key parent or tax, and same database, then create. I want to do this on the data set level, one data set at a time, and I will have a subject procedure to call it. So two procedures, one to get the entire subject taken care of and one to do all the work for foreign keys. Definitions, no definitions. I should. Definition to data point type already exists, so that's good enough for me. So some data entry, I have to enter 3 rows of data to create a foreign key enforcer. Taxonomy ID, I cannot find. Ooh, I want this one too. Primary key implied, cleaning, is this right here. This should be the primary key. So it has to exist in the table. I will add that. It is a foreign key. It just so happens to be in the same table. No problems. Do I have my specific data set number in here? I do. It's 15. Sweet. And I already have most of my stuff up from earlier. Definition to data point type 1009. 1009. These are the 4 keys that I care about. definition to data point type, and I remember it's 15, and this will be 13. Oof. And I just have to create a new definition. Do I want to create a new definition type? Yes, I do. I want to be as specific as possible. This one is for foreign keys. Is that a data point type? Yeah. It's to relate data point types. No, it's not relate. Is to something. It's used to determine what data point types need foreign key constraints. '21. Boom. So now I have this definition to a data point type, which means I can once again steal some code, because why not? Do we ever want to drop a foreign key constraint? Recreate it? I don't think so. Okay, so use interface. That's where all my code goes. All right. For this dataset procedure, my incoming payload will require dataset ID. That's not, oh, 1 is 1, I know that. So that will be my procedure, and I will need a dataset ID. Source. I will need a dataset ID of the foreign key. I will need the names for both, so I will focus on one for now. And I will need the database ID. So that will give me this, this, these. So I need data points. One dynamic SQL. And a relationship type. Yes, and a relationship type. But I don't have to do anything fancy since it'll be a wherein definition to data point type. All right. Set the SQL base. So this will be dataset name, source. What's the table that's going to get affected? Source. With check at constraint, name, data point ID source, destination, source, check constraint, source, destination. So we'll do destination next. Instead of destination, we're going to call it what it is, foreign key. So our dataset name for the foreign key, that's what it references. That's the other part of the name. And these are just names SQL generates. So it works out for us. We can follow their pattern. And this will be the data point name. Source. Because it references the data point name for foreign key. Awesome. So we will then get dataset ID from JSON payload. And get the information that we need. So we need dataset name, datasets, database ID from dataset select. Dataset name and database ID from dataset ID. All right. So now we have that. We can say iterate through data points in a specific relationship, system relationship type / definition of, let's just get a couple trees up, system relationship and tree for definition, so I can just get key names because it'll be better. Where we need give it a new type? It's just the definition. I just didn't change it? Or did I not do it at all? Did I skip a step? Oh man, I skipped a step. Foreign key container. This definition is just a container for foreign key data point types. So the way these trees are constructed is that we won't get there we go. Constraints, foreign key constraints. Yep. So that will be that one, and data point type. Wait, then what did I relate it to? 21. The wrong thing. 29. 21 should be 29. And what's our relationship? So 1009. Yeah. Ten, 11, 17, 24. 10. 21 as I put, 29 is what it needs to be. 10, 11, 17. You see the duplicates. 24. There we go. Should I be more specific? Yeah, I should. Should be a part of a foreign key. $29, 1009, 10,009. It is a data point to definition type, but really I don't want it mixed in with the defaults because that may or may not cause problems. when we think of how we want to query to see what we have, if I looking at normalization, I mean, this is, I'm going to pull the wiki too. Normalization wiki. This right here. This is why this system exists. Is we don't need to restructure our tables, but we want to neutral to query statistics. And it's like, what does that even mean? It's like you have to query it a specific way. So without defining a new relationship type, technically I have to, you know, it was wrongly classified under default. So in order to figure out what belonged in the foreign key, I would always have to include the definition it was related to. So I shouldn't have to do that. And that is, you know, this is just what we're looking at, is why is this system so normalized? Why is this so crazy of a system? It's because we are trying to get all of these to the topmost level. No, you don't have to query it a specific way. That's why we're creating a procedures with different entry points. Yeah, well, you know, I mean, to me, it does, but I don't know. So these are the other two things. To reduce duplication, having a name attribute so you can have 15 first names. I mean, it's true. Someone could have multiple first names and change their name over time, but just one person field with a first name doesn't do anything, or a person table with just one first name, it doesn't represent what it is. So just throw that out there for the stream, is I messed up, and we really want to be very specific when we classify something so we can only look at what we're asking for. And those are these two things, where our definition and our type ID. So we want the data point IDs and really data point ID doesn't really matter. It's the data point name that really matters from this table. Data point dataset ID is this table source, and the data point type ID exists in this relationship, where it's in this system relationship, it's the primary key child, where the system relationship type ID is this guy. Place tab with quote, comma, quote. Just give me a head start. We are running it. We are the system. And the other side of the relationship, whoa, I did that wrong, but I still need that. There we go. And the other side of the relationship is the definition ID. And we could say definition key name is foreign key. However, if we ever have a foreign key key name, we'll get multiple IDs back. So there's a possibility for a collision, and we don't want that collision on this. So we're going to be more specific. We only have one definition ID in here, but to be even more specific is we will take that definition name, or that definition key name, to make sure we're only getting one thing back, which is this foreign key container. And just because the reason why we use key names is because a name can change in the system if somebody wants to look at it differently when pulling data. And if you change the name, then the code might get upset, might break if you're saying, oh, where name equals. It's like, well, you can't. You shouldn't do that. So if we say, hey, you know what, you can control the name, but we, the developer, control the key name, then they can do whatever they want. And we know that if we change this, we will break our system, so we have control. So give me all the data point names in this relationship structure, but we are going to iterate through them. And what we learned, because we're modifying the object itself, we actually have to make this static forward only, read only, which is essentially the same as fast forward, except fast forward operates off the data set, static makes a copy. So it's unfortunate, but that's what SQL has been yelling at us about. And this is our data point name for the source. And let's see, there might be a possibility, just in case, I'll get the data point ID from the source in here too. I feel like I might actually need that. All right, so we can so we can actually iterate through that. So what do we get right now? Nothing, because is 1 actually a data set? I thought it was system. Ah, there's the issue. Yeah, there's the issue. All right, so I iterate through it, and now I have the data point name. So now I'm running through a table with those 4 things that we've defined: the foreign key parent, taxonomy ID, and the primary key cleanse to. So now I have to figure out, based on this name, where it came from. So I can say select the dataset ID foreign key. I'm going to need all of this. Except for instead of source, We want the foreign key information. But we won't have this. We need that. The only way we're going to get what the foreign key is where the dataset ID is in. Dang, keep hitting insert. Control insert is paste for some reason. I want the data point dataset ID from the data point table where the data point name is our source and the data point type ID is a primary key. And because the mistake that I covered at the very beginning of this stream, which was setting variables inside of a cursor, if it doesn't get any data back, it will hold on to the previous values. I want to make sure that I set all of my internal cursor variables to null. So what this will do is this will take the data point name, find out where it is defined as a primary key, and give me that information back. Now with a couple of quick checks, I can actually do this. So I'm gonna do a different technique where I just want to say, you know, can I build flag? And I do this when I have a couple of things that matter, but you know, I don't want to create nested if statements. I just want to say, you know, if the database for the foreign key and the source, if they don't match, then set I can build equals 0. I'm going to say at the very beginning, can I build equals 1. So yes, you can build it. Now it's going to get my information, and now we're going to just do a couple checks, right? Do the databases match? No? Well, you can't build it. If they're from the same table, that's okay, because that's how we get our cleanse. So what other rules? Actually, I don't think there are other rules because we take care of them in the relationship. So maybe we just say our execute is our base. And since we're doing, actually, this is per data point. SQL base, no, SQL execute equals replace SQL execute something with something. 1, 2, 3, 4 at minimum. write this better. Dataset name, source, dataset name, foreign key, data point, name, source, data point, name, foreign key. Print. See if I missed anything. Boom, missed something. Oh. Yeah. I can go the other way. That's right. This is the issue right here. Why don't I do it this way? So get the dataset ID foreign key from that data point table where it's the primary key of what I'm looking at, and I can get the data point name since I'm here. Data point ID since I'm here, and then don't need this. I could just say bam. Come on, what's null? Wait, what? Oh, there we go. In some cases in my system, if I have a date ID, it's a foreign key to the date table, but when it has a specific meaning, we use underscores to denote that meaning, because this is the primary key of this table and this is the foreign key. Same again, we'll have a group ID table, and all of our tables have a group ID tenant. So I just have to take this off and say the source. We would want the left of the, nope, can't do it that way, because if it doesn't have one, it will fail. So let us keep things separated. Source transform, where we are going to, for every iteration, when we reset the can I build it, we will reset the data point name. And then we will transform the data point name. What and where. Set the transformed version equals the left of the transform. It's going to get a little long, so the length of it minus the char index of this, and I think left I don't have to do -1. I don't think I have to do it again. We will see. Else, actually, else you don't have to do anything because it's already set. We're just making one slight modification. So let's see if it changes. Nope. So does that mean I have to add? It's one of these data set. Is that what I did? Oh. That's for right. -1. There we go. I get my left and right mixed up. There we go. Sweet. So let's just see if we get, oh, database. Yep, did that again. No squiggles, so this looks right. On cleanse 2 references the primary key. So now I just have to add my use database clause in there, and I will have the database ID. So one more, no problems. So use database name. And I'll wrap it because I don't really care. I just want to make sure that it's there. And try, begin catch, and error message. The if exists on some of these suck. I wish they would expand die, drop if exists more often, but I don't want to drop a foreign key if it's already there anyways. So when I have my data set, I will just say database name. Doesn't matter if it's source or not, because they should be the same. But we want to pull it from the source. Find a place for it. Boom. Boom. Easy enough. So we should be able to just run this right now. Ah, thank you. Sweet. That's exactly what we want to do. It cannot create it because, well, it already exists and we're not asking it to drop. So that would be it. Execute. Only if none of our checks failed. Sweet. Sweet. So this will be another procedure. A bunch of functionality today. That's really good. Finish the table creator up. Got our defaults. Now we get our keys. I think it's about lunchtime anyways. 12:30. Good time. It's kind of what I really like about this model is, yeah, I'm going pretty hard and I understand what is going on here. Oh, that should have been header. But, you know, thinking of a normal 9-to-5 job, just before lunch, we have these system tools that are really powerful. It's not a function, Elric. These are constraints. Actually, it's SQL. They're not constraints, they are foreign keys. Boom. And in the spirit of this, again, if we work in patterns, we can say foreign key. Did I plural it? I pluraled it. No problems. And we could say from subject, nothing changes except what we are calling. So not only do we have that same entry point for a data set to do the work, now we can send it a subject. And there we go. Oh, except for alter. Sweet. So I should be able to refresh my cache, get my parameters, and before I take off for lunch, I want to run this to make sure that all of my keys come back for messages and family, and hopefully I don't get an error so I can actually eat foods. We're gonna be the operator. Our subject ID, because if it's going to fail at the subject level, then it's going to fail. I mean, it's going to fail at the dataset level, then it's going to fail at the subject level too. So execute one of our foreign keys from the subject. This would be our output. And just to double check, what subjects do I have? Messages is 15? Yes. Alrighty. Nope, missed my declaration. So, hit a button, should get all my keys back, no errors. Could not create constraints. So some of these are firing when they shouldn't be. I mean, I'm getting success. This is what it should be. But for some reason, because I didn't have any of these, I'm getting a bunch of errors. So it looks like it's processing things it shouldn't be. why. Let's see if it can tell us why. Let's do a separation so I can see each execution and then figure out what it actually is. Oh yes, I know. It's my database trigger. I really hate SQL sometimes. So this, what's going on is because I did create new stored procedure like this, there's this thing in the background that thinks this is new. So it's telling my trigger that it already exists. It's like, well, yeah, I know. I just created it. So now I have to just open it like this. And that flag is different. So I can save it, no problems. It's ridiculous. But yeah, let's see what it's trying to do. Realm, well, that should have worked. Oh, it's on subject. Subject. Oh, it's doing it for everybody. So that means these are wrong. Both of them are wrong. Well, cool part, glad the whole system has the keys it needs, but horrible part is it doesn't look like I am filtering it down. And system relationship parent applied equals this. I was wondering why the other one took so long, the defaults. It's like 2 seconds is kind of a long time. Damn it. Oh, wait. No, it's going to do the same thing, isn't it? No. Sweet. Yeah, I was wondering why this was taking so long. Is because, well, we're not filtering it down by the parent. So yeah, that's exactly what we want. It's like a whole second. It's like, why? So I'll filter it down by the subject, so you're only running defaults for one subject. And then it's done. Makes way more sense. All right, but that's good steps in the right direction. Foreign key enforcement. And we tested it. So there is not much left, but there is a lot left. So we have a lot of views to create and view triggers and different functions, but yeah. So this is nice. A couple of nice pieces of functionality. After lunch today, I will roll the dice to see if I will be back just to work on this a bit more, because I want to get this done as soon as possible so I can start just grabbing files, throw them through a simple React application so it will just load data into the system, whatever data it is. I think that's what's going to demonstrate the power of the system. It's not that it's complex, it's not. It's just a pattern. It's a pattern anyone can learn, but the fact that it just models everything, no need to do anything else. A lot of time between now and then, but today was great. Today we verified that we can enter in a new subject of the realm class family type variety, which we did with messages. Hit a button, it created our message tables. Then we created the ability to dynamically drive our defaults, including getting data from a function. So not only are we doing true, falses, and nulls, but we are doing a more dynamic default. And finally, foreign key enforcement, which also super important thing to do. So 3 major pieces, one of them we did yesterday, but tested it today, and 2 brand new pieces of functionality. So thanks everyone for watching. Hope you enjoyed.